about a half dozen people, and you and I attending this right now, and I expect that number to start climbing very rapidly. I see a couple of names I'm very familiar with. I got some new people here, and again, thanks to everybody for giving up a late Friday afternoon. I think when we said the last Friday of the month, we didn't quite realize that sometimes that would be before a 3-day weekend. So little apologies on my behalf on that. As I say, this is going to be recorded. It will be available to everybody on Unico University, and I believe it's available on our website as well. Our web design person has, strangely enough, taken today off. So I've got 2:59 on the official clock right here, so we're going to start this up in, let's start right here. If there's any problems, if anyone can't see or hear, please type in on your chat bar now. So as I say, as I told you, Trent, it's kind of like talking on a radio station too. You can't judge anyone's reaction. So I have it's taken me a little bit of time to work with this. So it's a kind of a strange phenomenon talking on this. All right. Well, I think it's about time that we'll start this up, and as I say, welcome everyone, and I hope everybody had a nice summer. I know it was a bit on the cool side in most of the United States, but we can't do anything about the weather, and it really didn't seem to affect our business too much one way or the other. Was that the same with you, Trent? Was it a good summer for you guys? We had
overall a pretty mild summer. There was a couple hot spots, but overall it was mild. So
did it affect business at all?
I've stayed pretty steady this year. It's been pretty busy.
I don't really think that people go out, hey, it's really hot, let me buy an air conditioner. If we sold window airs, it might be that way, but with central air, that's really not what I have found to be the case. So again, I'm going to start this off. This is this month's edition of Pints with Pete. And this is about indoor air quality, IAQ. This is a big buzzword out there. This is something that is getting to be more and more discussed. I think it's starting to get more in the public's attention. And I'm going to turn it over to this slide over to you, Trent. What is IAQ? What we keep hearing those three letters out there. What is IAQ?
Well, overall, the Center for Disease Control will classify indoor air quality, or I should say, classify the pollutants that affect indoor air quality as gases or VOCs. These are going to be what's in everybody's home at elevated levels. Off-gassing is going to come from man-made materials, fire-retardant materials, paints, coatings on cabinetry, carpeting, bedding, furniture. So everybody's home is filled with items that off-gas 24 hours a day. And they're probably the most dangerous of the three categories and the least known within the industry.
Very good. Very good.
The second classification would be bioaerosols. Now, bioaerosols are basically what we're talking about, airborne living matter. That's going to be some of your molds, your spores, viruses, bacteria, all along the lines of anything that's a living organism that does get airborne that we can breathe in or ingest. And then the third category would be particulates, which would include dust, things across those lines. Probably something that as an industry we've done a lot better at dealing with as far as the residential purposes.
No, I think the same study had when I have read that indoor air quality is one of the top 5 health hazards in America.
And that's true.
Is that your too?
Yes, that's very true, and that's what's causes a lot of people's sickness throughout the year. It certainly affects people's health, comfort, and safety. And as a society as a whole, we're becoming more health conscious. We want to be healthier. So there's certainly a willingness, or a market, I should say, for people's interest in indoor air quality.
All right, very good. Basically, I have four factors that improve indoor air quality, and that would be better filtration, better humidification, and providing fresh air. And then lastly, this is a little bit controversial, UV light. So we're gonna cover all those categories.
Sure. Now, when we talked about the three categories that the CDC classifies as indoor air pollutants, if we would start off with particulates, we're going to use filtration to arrest or remove particulates.
Trent, I just lost you for a second right there. We had a little glitch, and I'm going to apologize for that.
Oh, no problem.
This is going to get to the heart of our matter today. First of all, with Unico, return air, a little bit different than conventional systems in the fact that we are not using return to keep the airflow circulating in the room. So again, normally have one return. The big thing is we don't want return air systems that have more than 0.15 inches static pressure resistance. And the big thing that we can do is we only require 150 CFM per ton instead of 400 CFM per ton. So the big thing is we don't want to have a filter that's more than 0.1 inch static pressure resistance at 250 CFM. So again, for further details, we have a tech note number 106 on this. And again, you can see filter right here with electronic. It's an old picture, by the way, Trent. We show what we have in terms of resistance drops from electronic up to electrostatic. The filters that come with our system are disposable filters. I'm not proud of this, but I would go down to Walgreens and buy a replacement for about $1.50. And these are our minimum rated sizes for our system. So 14 by 20 all the way up to 20 by 30. And all those are sizes you guys carry, right?
We don't actually manufacture or carry 1-inch filters, but we do have box filters that would be of those dimensions.
Right, as they say, our focus is my old boss say to keep birds and elephants out of the system, but that's about it. So that's so this is what I'm going to let you explain MERV.
Sure. Basically, as an industry, we try to classify filters by how well they can arrest airborne particulates. They've created a MERV rating. You're looking at your 1-inch filters that's going to fall in a MERV rating typically of a 1 through 4. These filters, whether they're fiberglass or pleated, are never going to catch more than 20% of the airborne particulates. And when we say 20% of the airborne particulates, we're really talking about the larger particles that are moving through the duct system. All the smaller ones are going to move right through them and get recirculated through the supply. As you move up through a 5 through 8 MERV rating, we're now talking about an arrestance factor that can capture right about 35 to 75% of the airborne particulates. And as we know, most box filters that are incorporated into a Unico system are usually going to typically start off at about a MERV 8. As you start getting in through a MERV 9 through MERV 12, you're talking about enhanced filtration. This is going to be able to capture 85 to 95% of the airborne particulates. We're now starting to get into the smaller category, some of the smaller particulates that get circulated through the duct system. And then once you break the threshold of a MERV 13, you can classify that filter as basically offering you better indoor air, and that would be considered a Group 1 filter, which can capture over 95% of the airborne particulates. And again, we're talking about bracketed percentages, but essentially we're also, as we move up the MERV scale, we're talking about the smaller particulates being trapped instead of being recirculated. When you do get to a MERV 16, that's going to top out the MERV scale. That's going to be able to capture well above the 95% threshold of the airborne particulates. And then the only thing that's going to do a better job at that is a whole house HEPA. HEPAs can actually capture 99.7% of the airborne particulates. And now we're talking about the really tiny stuff when you're dealing with a HEPA filter. A good way to look at it in your mind's eye is a human hair. If we took a human hair and measured the diameter of it, depending on your origin or nationality, you're really looking at about 70 to 100 microns. When you're dealing with a HEPA scale, you're going to be able to remove 0.03 microns.
Wow. So what's the bigger seller? How does the sales breakdown work?
Well, that's a good question. That's really going to depend on the people offering the systems. If, again, we have a more health-conscious society, so if you can get the contractor to present options to a homeowner that's going to offer them a more healthy lifestyle, surprisingly or unsurprisingly, depending on which way you look at it, they are going to more often than not opt for the better filter, which is going to be more expensive at the end of the day. Probably the highest selling filter for your standard box filter type is going to be somewhere between a MERV 8 and a MERV 13, because those are the most common box filters available.
Now, when do the tax credits and the health credits and all that set in? When you reach MERV 11 or MERV 13, or what is the rating?
Most of the tax credits or utility rebates are going to be centered around the motor bearing equipment efficiency. I'm not aware of any rebates that would be aligned with what type of filter you purchase.
Well, we're actually involved with the Green Building Association, the U.S. Green Building Association, the lead LED people, and they have a point scale. But I believe, Trent, you get so many points when you get above MERV 11.
Okay.
And the higher the MERV rating, the more points you get for your house. So that's something that you might want to look into.
Okay, yeah, certainly. That sounds good.
So I'm going to have to, I got this off of our chart, and I'm not an engineer. So we have right here our sizes showing the design air FM. And then we have velocity for the filters and the acceptable resistance. So basically what we're saying is we have a lot less resistance than a conventional system. So if we were to take a look here, this is a little bit, do you understand this chart? You're better than I am if you do.
Yeah, this looks like really you're trying to orientate filters that are going to offer the minimal amount of resistance based upon your CFM. You've lowered your CFM, so that also obviously gives you a larger threshold or opportunity for different types of filters.
So with your product, I happen to know the AC22, with our 3-ton system, we only need to move 750 CFM with that. We have a resistance of 0.07 inches static pressure attached, which is acceptable. And what is the AC22 MERV rating?
That's a MERV 11 filter. It's a pleated filter.
Okay. So that would be, again, where the green building people start their ratings with. So as I say, I've got your electronic air cleaners. I understand electronic air cleaners aren't as popular as they used to be. Is that true, Trent?
Well, really, as we went through the 80s and early to mid-90s, it was the only filtration device out there that was able to eliminate or annihilate airborne particulates, bioaerosols. So we're talking about the molds, the fungi, the yeasts, anything that has spores, bacteria, viruses. Electronic air cleaners would do a good job of eliminating them from the air. They weren't able to deal with or handle VOCs, and they weren't their best for particulates either. Oftentimes, people who had electronic air cleaners in place for a number of years would find a buildup not only throughout the blower compartment, but customers would often complain about particulates on the surfaces that were never there before electronic air cleaners. So they do a pretty good job because, again, they do have a pre-filter, and they do polarize particulates that move through the filter, and they have a tendency to zap them. I don't know if you're familiar with them, but they do make noises as particulates enter the chamber. Some of the smaller fallout from what would get through the filter would come out as a white form dust, and that would be an objection to some homeowners. But again, at the time, there was really nothing else to deal with people who had allergies to mold or mildew, or couldn't deal with or had a low threshold or low tolerance in dealing with some of the bioaerosols that would come through the system. And this kind of pioneered the ability to eliminate a good bit of that, and really up to 99% of it, when the filters and the cells were clean. And that would usually require a homeowner to do maintenance on it about every 60 days in order to maintain that 90% threshold.
Trent, we have a little technical issue. When you're not on, you can mute your phone. We're getting feedback. So, are you muted now? Are you on a cell phone or are you on a landline phone?
I'm actually using the computer.
You're using the computer. Okay. Is there a way you can use the phone on your end?
Hang on one second.
If you can't, I think I can do it here.
Yeah, I'm not seeing where I can do that.
All right, let me do that. All right. I'm not getting any feedback. Can everybody hear me okay? If there's any problems, I know we had, John, you said you were getting feedback, and I was getting that too. Forgive us, it's our first time with doing a long-distance call like this. But the next step that we have here, and I'm going to turn this over to Trent, is high media filters, and I think this is probably the direction that and I'm going to turn Trent's phone back on. Trent, you want to talk about high media?
Sure. The benefit of the pleated filter, the high media filter, is the surface area that's involved there. There's a series of pleats that are 6 inches wide, so it takes a lot longer for them to get plugged or the need for them to be replaced. They also offer far less static pressure. So a lot of contractors opt or prefer to use something like this as opposed to a box media filter just because of the sheer filter space.
Okay, and that brings us to our next category here, which I'm a little unsure of, which is called the MAC filter. So what is an MAC filter? So what is an MAC filter?
MAC filters are basically media air cleaners or box filters. The box filters still pretty effective. They're usually going to be rated somewhere between a MERV 8 to a MERV 13, and their effectiveness is based upon their MERV rating. Most MAC box filters, the majority of them that are out there with the more popular brands, are going to be either a MERV 8 or a MERV 10.
Okay. So as I say, we have a wide choice of filter. Now, humidification, again, a lot of the times, Unico systems are installed in unconditioned spaces. We at Unico do not recommend humidification except with a freestanding humidifier if the system is located in an unconditioned space. However, the thing is to remember with Unico, we are at a higher static pressure. We do use smaller ductwork. basically with Unico, with one exception, we put everything in on the return air side. So when it comes to humidification, these are the two big types that we have, the steam humidifiers or the power humidifiers. And again, we do not recommend bypass humidifiers with Unico. They just don't work because of the pressures that we have. And I'm going to turn this over to Trent now because, again, I don't know, with us, you put the steam humidifier on a return air side, you're not going to have quite as high a temperature as you would with the conventional system. So, unmuted. How would that affect performance?
Yeah, when you're dealing with steam humidification, you are injecting pure vapor into the ductwork. You really don't need to be concerned with the temperature of the ductwork so much as you would with a flow-through type humidifier that's actually trying to pass grains of moisture from an evaporative pad. Steam humidification, I would say probably 70 to 80% of those installs do go into the return side. So there's nothing to be concerned with there. The fan assist units should only be installed on the supply side. So if that's a factor with the Unico, then we'd want to probably avoid that if you have to go to the return. You drastically reduce their capacity when you put a fan assist humidifier on the return.
So that's interesting. That would be true with conventional systems. The steam humidifier, like your relief, would put on the return air side.
Yeah, you're not going to have any deficiencies when you put the steam unit on the return side because, again, really the only thing you're doing when you disperse steam in the ductwork is spike the relative humidity. You're not really relying on the air itself to transfer grains of moisture. With room temperature or return air temperature, it's very difficult to transfer grains of moisture from an evaporative pad just because cooler air holds less moisture. Now with a steam unit, you're not going to run into that deficiency only because the steam's going to give you a steady output and it's going to directly affect the air that's moving past it by spiking the relative humidity.
So this is your fan assist model. Tell them a little bit about your model 1137.
Yeah, the fan assist models are very popular because you avoid the bypass altogether. They're a little more efficient in that respect because you're going to be dumping the moisture directly into the warm air plenum, or the supply side, I should say.
All right, very good. Well, that kind of does it for humidifiers. Again, this is the big thing that people are talking about today is ASHRAE 62.2. Problem is, now we sell probably 75 to 80% of our Unico systems on older houses, but with new constructions, they're building houses so much tighter today, we're not getting the airflow. We're not getting the air changes. We're having problems with, this is what really leads in to all the problems with indoor air quality. You build a house like a walk-in freezer, you're going to have problems. So now we have to pull in fresh air, and that's what the ASHRAE 62.2 standard requires. And I have a question that just came up, and I want to make sure that we answer that. Okay. I believe this question from Chris would be one that we would like to, I'd like to have Trent answer. How much will fresh air affect the humidifier? I hope I read that right, Chris. Trent, do you have any suggestions on that? How much will fresh air affect the humidifier? The steam humidifier, rather. Let me unmute you there. Sorry about that. So did you get the question there? See it on the screen there? Did you get the question there?
Yes, it did. Yes, it did, Pete. The main thing whenever you're bringing in fresh, unconditioned air, you're going to negatively affect the space, whether we're talking about the winter or the summer. If his question was focusing on we're using a steam humidifier, we're bringing in fresh outdoor air, basically you're just going to add to the load of the humidifier.
Mm-hmm.
If we bring in cool, dry air into the space, then the humidifiers and the heating system is going to have to make up for that. Now, traditionally, Unicos are going to be used in cooling primarily. Is that correct?
Mm-hmm.
So
That's
if we're
the majority
bringing,
of our jobs.
so if we are bringing in fresh outdoor air, which because of the codes and ordinances in place currently, there's going to be that. Then what we're doing is we're bringing in excess humidity that either a dehumidifier or the air conditioner itself is going to have to fight. One consider.
Unmuted.
I'm sorry about that. One key thing to consider here is when you take warmer, high humidity air and bring it into a conditioned space, similar to what we were talking about earlier on humidification, cold air holds less moisture. So when we do bring in, let's say, 80 degree, 65% relative humidity air, that's going to happen naturally through infiltration or ventilation, then that relative humidity spikes up when it hits the cooler conditioned space. So it is a good question because it can certainly affect the quality of air you're dealing with, whether you're dehumidifying or cooling.
And we are changing our software program. We're going to have this out probably in another month or so. It'll start to appear as a software and firmware upgrade to our EC motors that will incorporate the ASHRAE 62.2 standard. So if you guys have been to our classes before, know what the EAC terminal is on the EC motor assembly, that we used to say electronic air cleaner, that now can be used instead to control a damper, like a 24-volt 6-inch damper. So that's a very simple way of doing it. That will be something like this. Again, let's apologize to Trent. I didn't get this off of your website, but it's the same idea. You bring in fresh air from the outside. You have something to prevent birds and all from getting inside of it, and then you dump that into the return air. And then this is the way we'll be able to do it with the 24-volt terminal. You just hook that up to the EAC terminal, and it gives you the choice. You can either set it up to conform to the ASHRAE 62.2 standard, or you could get in a fixed percentage. And the problem is, though, this is where we run into ERVs and HRVs, which you guys are I'm going to let you talk about, because the problem is we got down to 12 degrees below zero. I think up in Jim's territory, it got to 30 below zero. You don't want to be bringing in 30 degree below zero air. So that's why we came up with HRV. So you want to tell them a little bit about, again, explain the difference between ERV and HRV.
The general difference between ERV and HRV, we'll keep in mind both of them will reduce the spike in differences between the outdoor temperature and the indoor temperature. So there is actually a solid core in both units. As it brings in or introduces outdoor air, it goes through a core that's going to transfer the heat or the lack of heat from the indoor treated air. The best way to look at it is if we just piped in fresh air like we talked about earlier, you're going to be bringing in untreated, unwanted air. Nice thing about ERVs, HRVs is they exchange the heat. You reduce the temperatures like you're saying. If you're going to be in a very cold climate and you want to bring in fresh air, it can be moved through this solid core. So let's say we're at 68 degrees inside, 20 degrees outside. When that air gets exchanged and the fresh air comes in, the stale air goes out, you can probably be delivering somewhere between 60 and 70 degree air, maybe the low 60s. And that's really going to minimize not only an efficiency standpoint, but also a humidity standpoint. So if you're going to compare the two, ERVs are generally used and preferred in the southern climates because they're a little bit better at dealing with the differences in humidity. HRVs typically going to be used in the northern climates because they're more focused on the heat transfer or the better efficiencies therein.
Just a couple questions came up. See the chat board here from Chris about the chilled water coil, and he had another one about cooling in the hot water, cooling and heating with the higher temp. Can you hear me, Trent?
Yes.
Can you see this on your screen?
Right now I have a picture of the ERV HRV equipment.
Okay, well there's two questions that came. I use saltwater coils with geothermal for both heating and cooling, and he wants to know if in cooling will it lower the discharge?
Using an ERV or an HRV?
Mm-hmm.
Typically it should be unnoticeable in most instances. So I would say that if there is an effect, it would be very slight, because again, we're tempering the air that we're bringing in. So he's using a cooling coil to reduce the temperature in the airstream by piping in, okay, now I see that, piping in outdoor air. I mean, keep in mind we are transferring the treated air from the untreated air, so it's going to have a minimal effect, and you're mixing that with your return air. So you're going to have a smaller duct that's being treated through the ERV or HRV. You're going to have a considerably larger duct with the central return. I think a mixture of the two was going to be pretty much unnoticeable, but I don't want to mislead you. We are bringing in air that's going to be at a higher temperature than your standard return air. But again, once they're mixed, it's going to be a very minimal effect. I don't think you'd have a complaint or a deficiency within the system that would be recognizable.
Very good. Well, I have a couple polls I'd like to turn over to you guys. So just take a look right here at the screen. Just answer yes or no. All right, so we're going to open the polling, and we're going to leave the polling open for the next minute. Okay, well, polls opposed and an even tie. This is surprising to me because this is a big topic. Anytime you go to the ASHRAE show or Company Tech or anything like that, you hear about the fresh air all the time. So I want to turn this over now to our people, and he starts to ask questions. See if we have anything we haven't addressed. So just type in on your chat bar. Just as a reminder, the winner, who was determined entirely by my whim, will get a free 6-pack of beer to accompany their weekend. So any questions out there? Chris, you've done a great job of coming up with some good questions. Anybody else have some questions out there? I know it's the Friday before a long weekend, and I hope I still have some people out there listening. And Trent, I really want to thank you for taking part in this. I know it was a little discouraging there with the feedback we have from having you out in Novi, Michigan, and me over. Well, are you in Novi? I'm sorry, I muted you there again. But it's very difficult to try to coordinate things as far away as we are. So are there any questions out there at all? Okay. No, not quite. Let's give it 1 minute. I think I got something coming in. Well, Trent, I want to thank you for giving up your Friday before a long weekend to come in and listen to me. And I really appreciate all you guys as well, all of our customers, our reps, etc., for taking part in this. Again, next month will be another guest visitor We're going to have a gentleman who was a 30-year veteran of Sporlan, and we're going to talk about a very important topic, which is proper evacuation and charging of the Unico system. Now remember, with our new I-Series, those are pre-charged from the factory, but if you use Unico with the TXD, you do have to charge the system in the field. And we've had a lot of confusion about that. So again, thanks to Trent and everybody, and we'll see you next month on Pints with Pete, and this will be recorded to our website. So aloha and mahalo. Thank you.